Hello, Mr. Malo here, your online math teacher, and welcome to my channel. Today we're going to be talking about how to solve for side lengths in right triangles using trigonometry. So as we jump into this, we want to first remind ourselves of some useful information. First, this acronym SOHCAHTOA that we use to help relate the ratios of sides of a triangle to angles. Now, one of the most important things with SOHCAHTOA is this is all predicated on picking an angle in your triangle to position yourself at. So for this angle theta here, which I have also denoted with this red dot here, the opposite side to that is labeled opposite on this triangle. The adjacent side, so adjacent means next to, is this bottom side of the triangle, and the hypotenuse is that side that's opposite the 90-degree angle. That will always be true in a right triangle. But this helps us remember that sine is always going to be opposite over hypotenuse. So we can see that our ratio of sine of that angle will be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. So this is going to be really useful for us helping solve these problems. So let's jump into an example now. So what we want to do is we want to solve for the missing sides in this triangle. All of the, as long as you know one non-right angle, so one non-90-degree angle, and one side length, you can actually solve for the rest of the side lengths in your triangle using right triangle trig. So what we need to do is start by planting ourselves at that angle we know. Now we could go about finding all our angles here, but since we know this 37, let's position ourselves at 37 degrees here, which is this angle B, and opposite to that is going to be the side length between vertex C and A. Hypotenuse is this side length already labeled X, and adjacent is going to be the side length labeled 11. Now, when we think back to SOHCAHTOA, so SOHCAHTOA, since we know the adjacent side length, the versions that are going to be useful for us are the ones that use adjacent in that. So cosine uses adjacent and tangent uses adjacent. So depending on what we are trying to solve for, we'll want to pick one of those. In particular, you see that we have the variable x on the hypotenuse. So what we'll want to do is use the version of trig that relates adjacent and hypotenuse, and that's going to be cosine here. So what I can write is that cosine of this 37-degree angle, that should be equal to adjacent over hypotenuse. Adjacent is 11, hypotenuse is this unknown x. If our goal is to solve for x, what we need to do is we need to isolate x, get it by itself. So since it's currently in the denominator of our fraction, we need to get it out of that. So we will undo division with multiplication by x. So we will multiply both sides by x. We'll see our x will cancel on the right. We are now left with x times cosine of 37 degrees, and that's equal to 11 because 11 is the only thing left on the right hand side. Now we need to get x by itself since it's out of the denominator. To do that, we need to move away this cosine, and division undoes multiplication. So we are going to divide both sides by cosine of 37 degrees divided by cosine of 37 degrees. So we'll have those cosines cancel on the left here. And now this leaves us with x is equal to 11 divided by cosine of 37 degrees. So now if we want to figure out what that is, we can just go to our calculator, plug into the calculator 11 divided by cosine of 37, and we end up getting that this side length here is about 13.77 because I'm rounding to 2 decimal places based on my instructions here. I will note it is important that you make sure your calculator is in degree mode for this problem since we are given an angle in degrees. If we could go about solving for this last side here, and often I will ask my students questions where we do all of them, but in this case, we're going to move on to the next one. We'll do one more example of this to see. So again, we have a triangle where we know one side length and we know one angle or one non-right angle. So that means we can use our right triangle trig. So we'll again start by planting ourselves down at that non-right angle we know, that's 32. Opposite is x, adjacent is 13, hypotenuse is this unlabeled side. Again, we can now look to SOHCAHTOA to see what we have information about. So the side length we know is the adjacent one. So again, we will want to pick one of our trig versions which use adjacent, but this time we want to solve for that x on the opposite side. So what we are going to use is TOA, so tangent, because it relates opposite and adjacent to this angle of 32 degrees. So I will write tangent of 32 degrees is equal to opposite, which is x, over adjacent, which is 13. So this sets up my ratio. And now, once again, my goal is to get x by itself. So I'm going to, in this case, I need to move that 13 that's in the denominator. So since I'm dividing by 13, I'm going to multiply both sides by 13 because multiplication will undo division. So multiply both sides by 13. Those 13s will cancel on the right-hand side. And now I'm going to have 13 times tangent of 32 degrees is equal to x. Again, we can now go to our calculator. Make sure you are in degree mode because this is a degrees problem. So, and I get that this side length is now approximately 8.12. So x is approximately 8.12. And again, we could go about solving for our third side now. We could use either Pythagorean theorem or our right triangle trig, but this gives us the right idea on how we're going to use right triangle trig to solve. So I hope you found this video helpful, and this is all there is to it. I hope to see you again next time.